Hello friends, welcome to lecture 4 from Digital Logic Design. Today's topic is octal to binary, octal to decimal and octal to hexadecimal conversions from number system conversions topic. Now let us take the first conversion, octal to binary conversion. To do this conversion, first what is meant by octal? Octal means its value is 8. Should write this 8 in terms of 2 power n. So which is equal to 2 power 3. So that 3 bits are required to represent octal digit into binary form. So with these 3 bits, we should develop the truth table to write the octal digits. The total octal digits are 0 to 7 only. Okay. So to write this 0 using 3 bits based on the binary weights 2 power 0, 2 power 1, 2 power 2, 0, 0, 0, its equivalent value is 0. Similarly, to get the value 1, we should place 1 in the place of binary weight 1. Okay, in this way, we should develop the truth table. 7 means 4 plus 2 plus 1. So that in these 3 positions, we need to place 1s. So use this truth table to write this octal number into binary form. Now let us take the given number 436.72. In this 436 is the integer part. This is a fractional part. So for integer part, first we should start writing the binary values for each octal digit from LSB. This is LSB for integer part. Similarly, for fractional part, we should start writing the binary numbers for each octal digit from MSB only. This is MSB for fractional part. This is LSB for integer part. Now we should write the equivalent binary for each octal digit. So here 6 means 1, 1, 0. 3 means 0, 1, 1. 4 means 1, 0, 0. 7 means 1, 1, 1. 2 means 0, 1, 0. This is our required binary value for the given octal number. The next conversion is octal to decimal conversion. To do this conversion, we should apply the octal weights for integer part and fractional part. The octal weights for integer part starts from 8 power 0, 8 power 1, 8 power 2, 8 power 3 from LSB. For fractional part, 8 power minus 1, minus 2, minus 3, like this. Okay. Now we should take the given number 1436.72. Now we should apply the octal weights for integer part 8 power 0, 8 power 1, 8 power 2 and 8 power 3. For fractional part it is 8 power minus 1 and 8 power minus 2. This is just like a binary to decimal conversion. Instead of 2, we should use the 8. Now we should multiply each octal digit with the corresponding octal weight and then add on both sides. So its value is 1 into 8 power 3 plus 4 into 8 power 2 plus 3 into 8 power 1 plus 6 into 8 power 0 plus 7 into 8 power minus 1 plus 2 into 8 power minus 2. The equivalent products are 512 plus 56 plus 24 plus 6 plus 0.875 plus 0.03125. This gives rise to 798.90625 with the base 10. This is our result. Okay. The next conversion is octal to hexadecimal conversion. To do this conversion, there are two methods. The first one is octal to binary and then binary to hexadecimal, or octal to decimal and then decimal to hexadecimal. Out of these two methods, the first method is very easy, so that we should follow octal to binary, then binary to hexadecimal. Okay, but both methods will give the same answer. Now we should apply the first method. In this first method, first we should convert octal to binary. Okay, so octal to binary, the given number is 1436.72. For this octal number, the binary is, for 6, its value is 110. 3 means 0, 1, 1. 4 means 1, 0, 0. 1 means 0, 0, 1. Okay, this is for integer part. Point for fractional part, 7 means 1, 1, 1. 2 means 0, 1, 0. Okay, this is our binary value. This is the first part. The second part is Now convert this binary into hexadecimal. To convert this binary into hexadecimal, we should split this binary into groups with the 4 bits each. Okay, because hexadecimal means 16. 16 equal to 2 power 4. Using 4 bits, we can write the equivalent hexadecimal value. This is integer part and this is a fractional part. For integer part, always the grouping starts from LSB position. For fractional part, the grouping starts from MSB. For this integer part should starts from 0 to 1. This is first group. Next from 1 to 0. This is second group. This is a third group. Okay. Similarly for fractional part starting from MSB 1 to 0. This is the first group. Next only 2 bits we have. 1 0 only. So to complete the group we should place 2 more zeros towards the right side. Okay. So 1 0 0 0. Okay. This is a second group. Now we should write the equivalent hexadecimal digit for each group. To write the hexadecimal digit for this binary group, we should take the binary weights as 1, 2, 4, 8. That is 2 power 0, 2 power 1, 2 power 2, 2 power 3. Now we should write the equivalent hexadecimal digit. Okay. So its equivalent to hexadecimal value is 3 for the first group. For the second group is 0, 0, 0, 1. Its equivalent value is 1. For the third group, 1, 1, 1, 0 means 8 plus 4 plus 2. Okay, its equivalent value is 14. But instead of 14, we should replace with E. Again, 1, 1, 1, 0. It is E. Next, 1, 0, 0, 0 means its equivalent value is 8. Okay, this is our required hexadecimal number for the given octal number. This is using first method. Okay, here I will explain the second method also. The second method is first we should convert octal to decimal. After that, decimal to hexadecimal. Now let us take the given number 1436.72. This octal into decimal, we should apply the octal weights 0, 8 power 0, 8 power 1, 8 power 2 and 8 power 3. This is 8 power minus 1 and 8 power minus 2. Now we should multiply each quotient value with the corresponding weights. So 1 into 8 power 3 plus 4 into 8 power 2 plus 3 into 8 power 1 plus 6 into 8 power 0 plus 7 into 8 power minus 1 plus 2 into 8 power minus 2. This is 512 plus this is 256 plus 24 plus 6 plus this is 0.875 plus the total value is 798.90625 with the base 10. This is the first part. Second part is now we should convert this decimal into hexadecimal. So to convert this decimal into hexadecimal, to convert this decimal into hexadecimal number, we should divide this integer part with the 16 and multiply this fractional part with the 16. Now let us do the integer part 798 by 16. 16 fours are 64. So 79 minus 64, its remainder is 15. Now 158, 69s are 144. The remainder is 14. So instead of 14, we should replace with the hexadecimal digit E. Okay. Now 16, 3s are 48, remainder is 1. Next 16 zeros, remainder is 3. Okay. Now we should take the values from bottom to top. For integer part, the values are 3, 1, E point. For fractional part, now we should multiply with the 16, which is equal to 14.5. Instead of 14, we should replace with the E. Its integer value is E. Now we should multiply 0.5 into 16, which is equal to 8.0. This is 8. Okay. The remaining fractional part is 0.0. In the next step, suppose if we multiply this fractional part with the 16, the resultant product is 0 only. Okay. So at this level, we should stop the process. Okay. Now should take the values from top to bottom. Okay. So the fractional values are E8 with the base 16. Okay. This is our answer. Now we can compare the answer with the first method. Okay, both methods should give the same answer. Okay, in this way we should convert octal into hexadecimal conversion. When we choose these two methods, the easy approach is method 1. So it is better to follow this first method to convert octal into hexadecimal. I hope you understand this concept. If you like my video, please like, share and subscribe to my channel. Thank you.